Welcome to the second introductory video for Module 5A. In this video, we will compare different failure theorems. Besides the von Mises stress, two other failure theorems to consider are the maximum shear stress theory and the maximum normal stress theory. Primarily, these are for academic reasons in their consideration. The maximum shear stress theory is more conservative than the von Mises theory, whereas the maximum normal stress theory is not safe to use with ductile materials. So in this stress envelope plot here, we see the maximum normal stress theory. This is likely the most basic failure theorem. It states that if either sigma 1 or sigma 3 equals or exceeds the yield strength of the material, then failure occurs. However, this concept does not match up with experimental testing. Note that this line here is considered the failure line, where in the inside of this area, the design is supposed to be safe, but outside this area, it should fail. However, we find through testing that this theorem is accurate in quadrants 1 and 3, but these so-called safe zones in quadrants 2 and 4 will actually experience failures of test samples. The maximum shear stress theorem attempts to correct the issues with the maximum normal stress theorem. Note the adjustments made in the second and fourth quadrants. This concept postulates that failure occurs when the difference between maximum and minimum stress equals the yield strength of the material. This theorem better aligns with experimental data, but tends to be overly conservative, and passing test results occur in the so-called failure zones. The von Mises theorem is a further refinement beyond the other two theorems we've already considered. This concept is based on the hypothesis that yielding occurs when the distortion energy equals or exceeds the yield strength of the material. Distortion energy is the energy stored in a material due to changes in its shape under applied stress. This theorem most closely aligns with experimental data. Here is a plot of some test data against the three failure theorems. Note that the data most closely fits the von Mises theorem. Here is another plot of actual test results. This one is good because it tells us the specific materials that were used in testing. Notice that the carbon steel, aluminum, and nickel alloy all fall at or near the von Mises stress line. Now look at gray cast iron. It falls well outside the von Mises line, but inside the maximum normal stress line. This is because gray cast iron is a brittle material and von Mises is only for ductile materials. This also tells us that there may be some application of the maximum normal stress theorem to brittle materials. We will end this video here. In the next video, we will discuss factors of safety.